In this lesson, we will be solving equations using algebra tiles and integers. So here you're going to need, you only need positive variable tiles. So I just put some plus signs on my variable tiles, and then I took and labeled positives and negatives on my 1 tiles so that you guys can tell the difference. You guys can make it like this. I've also found a good link for virtual algebra tiles that you can use. So you will find the link to that, as well as I have a video that I've linked to this lesson as well on if you want to do this digitally and submit digitally. I created a video on how you can do that, where you can just cut and paste the picture of those virtual ones into a document. So that might be handy if you don't want to take the time to cut out, or if you would prefer to do it all online. That is totally up to you. So we're going to start with the equation or the example P minus 3. So I have P minus 3 equals 10. So I'm going to label this up here. And just like in the last section, I am going to do, oh, that was really bad. I'm going to draw a way straighter line, but still kind of squiggly, down that represents my equal sign. So I'm going to represent this. So P is going to be represented by my variable, and the minus 3 I'm going to represent with 3 negative 1s. So 1, 2, 3. And on this side, I'm going to have 10. So I need 10 positives. Eight, 9, 10. So this is P minus 3 equals 10. Now, I'm going to have to pull on some of my prior knowledge of what we did earlier when we talked about integers. Is when I have a positive and a negative together, they cancel each other out. So this here is a zero pair, is that fancy word that we used earlier this year. And so when I have a zero pair, I can remove it because this here is equal to 0. So I'm going to use that to create 0 pairs here because I want to get my variable by itself. And so in order to do that, I need to get rid of those negatives. So if I have a positive and a negative, that's going to get rid of those ones. I can add another positive here and another positive here. Now, the tricky thing to this is that I have brought these 3 in, but all of a sudden I added weight to this side. So that means that all of a sudden my balance scale is not the same. So if I add 3 to this side, I need to add 3 positives to this side as well. So 1, 2, I'm going to put this one here, 3. So I had 10. I needed to add those 3 in because what I do to one side, I have to do to the other. Now, this here is equal to 0. And so by me having it sit here or by taking it away doesn't actually change the value. So what I'm going to do is I'm going to pull these 3 off, or these 6 off, because when I have those 0 pairs, they equal 0 anyways. And what I'm left with, my P is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm finding that P is equal to 13. Now, sometimes I get a number when I do this that just doesn't really sound right. So what I can do is I can verify my answer. So I can plug it into my original equation. 13 minus 3 equals 10. 10 equals 10. So that means that I did a good job to get this. Now, this is a really handy tool when you're doing assignments where maybe you don't know what the answer is you can always check to see how you're doing by plugging it in. And so that's why we start by learning how to verify. It's so that when we get into coming up with our own answers, p equals 13, we can use the verification to make sure that we are on the right track. So we're going to do the next example. And I'm just going to read it while I take these away. So it says, at 10 a.m., it was cold outside. By 2 p.m., the temperature had risen 3 degrees, and the new temperature is going to be -6. What was the temperature at 10 a.m.? So we're going to start by writing an equation. So at 10 a.m., I don't know what temperature it was. So I'm going to say, let T equal the temp at 10 a.m. So whatever that temperature was, it went up 3 degrees by the time it hit 2 in the afternoon. So +3 is going to be equal to -6. Now, if you are following along with the examples in the notes, I do know that this is the opposite direction, or the opposite sides is what it was written there. The nice thing about the equal sign is, remember that if I have this and you have that, we have the same amount. So it's like me going to the store and buying a chocolate bar. If the chocolate bar is $1, I'm going to give the cashier $1, and she's going to give me the chocolate bar, and we're both going to be happy because that value is equal. So it doesn't matter if I give her the money first or if she hands me the chocolate bar first and then I hand her the money. The value is still the same. So it doesn't actually matter what order that goes in. So what we're going to do is we are going to do this with our algebra tiles. So I'm actually just going to move this over to the middle. So T plus 3 equals -6. I'm going to get my equals line in there, and I'm going to start representing it. So T plus 3 is equal to -6. So when we solve this one, we're going to do a similar thing to what we did in the last example. I still want to isolate my variable or get it by itself, which means that I need to take these away. Now, the big reason why we have to add a 0 pair is because if I take 3 positives away here, I don't have any to take away here. So we kind of have a problem. So what I'm going to do is I'm going to pair each one of my positives with a negative, and that's going to create a 0 pair. So I'm going to add a negative on this side and a negative on this side. So if you're using tiles, this is kind of a good way, I know I did it differently in the last example, to add one to both sides as you go, just because then you know that you're still doing the same thing. So I'm going to add one to this side, one to that side, and one to this side, and one to that side. So I've added 3 negatives on this side and 3 negatives on this side. So what I can do is these are equal to 0. They cancel each other out. So I'm going to take away that pair, take away this pair, and take away this pair. And I'm left with T on this side is equal to -9. Now, we can use a little bit of, we can do a formal verify where we plug it in, or we can use some of our reasoning skills. So if it was -9 and it went up 3 degrees, it would make sense that it is -6 now. So it's a good way that we can check that what we have is something that makes sense. Now, there are some practice questions here. They are focused on having those zero pairs and using them to help you come up with a solution. Please give them a try. You can use either homemade algebra tiles like what I have here, or there is the link to the digital version. On the digital version, you'll see that there are large squares. So they're not the same as these ones. There's these ones, and then there's a bigger one. You don't need to use those ones. Those are for something that you will learn in future years. There's sort of two options that'll help you with this. There's going to be a checkup on this next week. So get some practice in. Let me know if you have any questions, and I will see you next time.